Today is probably an interesting day in your lives. Why? Perhaps we are first team that doesn't have a physical project to present it today. However, who says that this is a disadvantage? We say no. In fact, the best projects are not only done in just 4 months, the best projects are done in more time. Today, we have come to sell you an idea, and probably the best project that has been proposed at the university. But what will that project be?
The project began with the discussion about the analysis of the TDS, Total Results Audit. One of these systems was a project done by the student from the 9th grade of manufacturing. After we found out some interesting data, the condensed water stored results to be good enough for human consumption in terms of TDS. However, there is still no certain that this water is completely safe. Thus, this became the starting point of the entire investigation as hypotheses were discussed between the teachers Rolando, Manuel, and the students of the 9th grade of manufacturing.
Water collection points. They are HA conditioning pipe drop points, or on the left side and or on the right side. These are related to age of the mini split inside the university building. Pipe jointing. Intercept or drop points leaving a visible outlet on the outside of the building. 10 joint them while PVC pipe will be sent to the system. 11 tracks pipe to the system. The pipe will be placed in the center of the top of the building where it connects to the drop points. This pipe will be sent with an inclination.
Rainfall water. University has 10 falls distributed throughout the campus. 5 on the north side and 5 on the south side. Each one of them has a trash filter. The best way is to intercept before it arrives to the drainage system from the first fall to the last fall, and then direct into a water tank which will be tried to supply the institution.
We made a little representation of the university in AutoCAD and nowhere H5 line pieces both at the rainwater and condensed water. I'll show you next in AutoCAD. The line color blue is the condensed water of the mini split, and the line color red is the rainwater.
This is a Chicago diagram that explains the methodology to carry out the collection of rainwater and condensed water. The materials are described below. For example, for forts, PVC, the connection, 18 grades sandpaper, paper cleaner, construction worker, 3/4 coupling, tank, 450 liters, heavy duty cable, plumber, check valve, 3/4.
Production of condensed water. To know how much water we can get from the air conditioning, we use the following information. Our university, we have 51 air conditioning. Each one produces 600 millimeters every 30 minutes. The air conditioning are working 10 hours daily.
So now, with the information that Aldo told us, we know that only one air system produces 1.2 liters of water per hour. In a day of a shift of 10 hours working, it produces 12 liters of water. But we have 51 systems in all the university. So in total, it will be 612 liters in a day. In a month, it will be 18,360 liters. We can produce with that amount of water 966 carboys in a month. We can sell them in 15 pesos each one. And in a month again, we can produce or earn 14,490 pesos.
How will we get the rainwater and how much will it be? The rain seasons are from May to October. The average rainfall of those months is 40 millimeters per day. I can rain up to 6 days per month during the rainy season. The measurements of the building are the 65 per 19.5 meters.
Baseline the operation to see how much water we can collect. We know that we can collect around 304,200 liters per month during the rainy season.
The question is the water from the AC good for humans consumption? Well, to know the parameters that must have water was investigated the official Mexican standard 127 WSA1 2021. Water for human use and consumption, permissible limit of water quality. First point of this standard, the water supply system must not have as a source trade wastewater supply. For the physical sanitary specifications, we have that the permissible limit of turbidity is 4 units, but intend to change it to 3 units. For the pH, is between 6.5 to 8.5 units. And true color is 15 color units. For chemical sanitary specification, we have that total hardness has calcium and carbonate. The permissible limit is 500 milligrams per liter. And total dissolved solids is 1,000 milligrams per liter.
Continuing with the explanation, we look at the table of the specification for metals and metals. The limit refers to the total concentration in the water, which includes those suspended and dissolved. So for example, aluminum has permissible limit of 0.20 milligrams per liter, acerbium with 0.025 milligrams per liter, or barium with 1.3 milligrams per liter. This is how the data was counted. Then there is the table of microbiology sanitary specification where the parameters are E. coli or thermotolerance coliform, and year lambda, which is only determined in case where the water comes from a surface source.
What is rainwater? Rainwater that is not absorbed by the ground but runs off through building, street, or other surface. Some advantage of this project, it is sustainable. It's a solution to the problem of water scarcity. The water is of high quality because choose as chlorine. Watering plants in dry season is activity that consumes a lot of water. Other point is independent system. We can save economically for the use of university. It reduces flooding and erosion when done on a large scale, and it is can use in cleaning if treated.
4 points is disadvantage. Point number 1 cannot be enhanced. Point number 2, it is not constant. Point number 3, somewhat strong initial investment. Point number 4 needs to be treated to be used safe. Treatment system. 4 points. Points number 1, a sieve filter. Point number 2, granular activity. Point number 3, reagents aluminum sulfate. Point number 4, pool vacuum cleaner.
Does this have a positive effect on our university? Well, the answer is debatable due to in our region it doesn't rain much and our rainwater income will be limited. However, if we take advantage of the rainy occasions, we can increase its use. As an example to observe the effect on our university, we have that it uses 369,000 liters per month, and our system is capable of collecting 304,200 liters per month for only 6 months. Therefore, we have a yearly consumption of 4,428,000 liters, and the rainwater collected will be 1,825,200 liters. That is, we will have a 41% return. If we convert this to pesos with the water rate, we have that the annual consumption is 43,793 pesos, and the rainwater collected is 18,052 pesos. In conclusion, with the implementation of this system, the university could save approximately 18,052 pesos per year.
Up to this point, we have already mastered the collection of water from air conditioners, but how will we convert the water from human consumption? The answer is simple. Thanks to the purification of water. How do we achieve this? Rule 127 tells us the answer, as in the following table. If we need to change the pH, we neutralize it. If we need to reduce the turbidity, then we filter. If we need to remove the heavy metals, we add the reverse osmosis membrane. Any parameters that isn't suitable from the water can be changed and improved thanks to this table. And with what device can we do these processes? Thanks to the following filters.
Reverse osmosis. The process purifies the water, eliminating, in particular in suspension, in the center part of the equipment in the membrane of proportion of 0.001 of the microns, remove dissolved solid, bacteria, heavy metal, mineral salts, and the other substance dissolved in the water. And as a result, having a good flavor. Softener remove and hardness and the water. Remove calcium and magnesium and the content in the water.
So the activated carbon filter uses the carbon as its main element. The carbon makes water impurities stick to its particles. The activated carbon is ideal for removing chlorine, organic chemicals such as pesticides, trialomethanes such as chloroform, and many volatile organic compounds that are components of gasoline, solvents, and industrial cleaners. Ultraviolet light is the last filter. This method provides the effective disinfection without generating residual effect that could have a harmful effect to humans. Ultraviolet light kills viruses, fungus, and cystices, and may be in the water.
So we already know which filters to use, but now we'll explain how the water collection process will be. First, the water from the AC will be collected in a first tank. Then that water will go through the activated carbon filter, followed by the softener. Then to the reverse osmosis membrane, removing all the heavy metals. And finally, we'll go through the UV light filter, removing all the bacteria, and then be stored in a special tank.
Thanks to the matter of manufacturing topic, it helps us to identify a very important part of the process, that is the storage. Maybe you will wonder if any tank can be used, but the answer is no. This process needs a polyethylenic tank. And how does this tank work? The tank is filled with a bottled water and sealed to prevent any type of contamination from entering, maintain a constant source of water, and doesn't generate odor and taste, and has a capacity of 25,000 liters.
Recommendation. It is recommended to carry out a periodic inspection every 6 months of the tanks in order to detect the possible contamination. An assessment is important to ensure that the water is safe for a human consumption. The other recommendation, if the water tank is kept clean and dry, it is possible to prolong the time of the water storage. It is so that the water be distributed automatically or manually as a convenience for the university.
Automatization. Is there any way to automate this process? The answer is yes. We can automate this process by three main things. The water level sensor is one of them. This will help us to detect if the tank is full or not, and with a signal we can use a relay or an Arduino. With this tool we can use that signal given by the water sensor level, and with that we can use many different ways to automate the process from the beginning with the tank of unpurified water. So it starts the process crossing through the filters and the osmosis reversal process until a UV light. So once it's in, it will get the purified water to the purified tank, and with this we will know if the purified water tank is full or not.
I will talk to you about testing for water quality, and one point that is important to know is that every month the health secretary will check if our purified water is fit for human consumption. So we will have to send our samples to water analysis laboratories, and we will have to carry out monitoring methods every 15 days to know our water quality. Parameters such as pH, turbidity, microorganisms, and heavy metals are calculated.
Test strips for water. The strips are very practical since they help to measure parameters such as pH, hardness, iron, chrome, copper, nitrate, and they are very cheap.
Water quality detector. It is a very effective portable that helps you measure the pH, salinity, temperature, and code, which are very necessary hits for the quality of our water purification.
Water tester evaluates the effectiveness of purification procedures on the performance on filters of water purification systems.
They are tests that help you identify the main bacteria that are present in our water, simple such as E. coli and coliformis. In addition, other tests can be found for different bacteria.
Such important predictability requires a generous investment. But how much money will take? We want to make this point very clear, so we leave you the following table with all to the cost.
The cost divided in three parts: cost of the fabrication, cost of the materials, and cost of the service. For example, the table have a material like a glued, PVC pipes, PVC elbows, ultraviolet sunlight, and tackle water. For another hand, we have the cost of the technique and fabrication like a workmanship and the technical service, and the cost of energy and cost of the permissions.
So, which is the total cost? We can see in the next table. The cost is 114,782 pesos. This is in a promedium for year. Going with the earning that we will get in a 1 year of the purified water and pluvial water, the utility will be of 77,195 pesos.
So, it is all? No. Actually, this project still has much more than giving, such as recover electric energy with the help of solar disinfection process. We can implement this idea in a government project, such as We Are Your Chain. This is gonna help to guide more students to think big and develop a good project and not just to pass matter. Increase plus the pluvial water collection area and get more water.
This is not a farewell, nor is it a closure, since we have a lot of work ahead of us that we are committed to doing. If you can help us financially to fulfill this wonderful project, we hope that soon you will be encouraged to complete this project for the next course. See you soon!